My question is, what properties distinguish ionic compounds from covalent compounds?
Perfect. Who would like to start us off? Anybody?
I will. What do you know about your question, Matt?
Well, I know that ionic compounds have something to do with the metal, and covalent has to do with non-metals, and that's pretty much it.
Can you give an example of covalent or ionic compound? Like any elements? Or?
I know one.
And what compound is that?
That's salt. It's sodium chloride.
Who can distinguish the two?
What is sodium? Is it a metal or a non-metal?
Does someone have their periodic table? Sodium's in the first row, so it's a metal. Okay. And chlorine. Yeah, it's in number 7, row 7.
So it's a non-metal.
Yeah. So that'd make it ionic, wouldn't it?
Yes.
Because it's got a metal right here. Alright.
Aside from the fact that there's metals and non-metals, is there any other way we can distinguish them, or would that be it?
I think that would be it.
That would be it? Okay, so we have an ionic compound. What about the covalent compound? Does anyone have a formula for a covalent compound?
There's water, H2O.
Okay. We already know it's covalent, so that has to be a non-metal and that has to be a non-metal. So we're good, they're both nons.
What about the electrons? Why do the electrons differ from ionic?
What do you know about the electrons?
Well, the electrons keep the whole compound stable, because protons and electrons, they're positive and negative, they have to.
Do electrons react differently from ionic and covalent compounds?
I think probably. Yeah. I don't understand what's the difference between ionic and covalent though, so.
I think it says in the book that in covalent bonds, they share an electron.
So in this case, you're saying that if I had an electron, both of these would share this one thing right here.
Yes. So H2O, water, shares electron.
Okay.
So the oxygen atom shares one electron with each of the hydrogen atoms.
Gotcha. Now, what happens in the ionic case?
It says here one electron is completely transferred.
Gotcha. So, ionics are transferred.
Do you know about the strength of the compound?
Yeah. The ionic is stronger because it's got a metal in it. And this one just has 2 non-metals, so it, like this is water. How strong is that?
Yeah, because it's easy to boil in. Yeah. Alright, I got you.
Ionic have higher melting point and boiling point, and covalent have lower melting point and boiling points.
Oh, I got it. Because it's a stronger...
Stronger bonds means higher boiling melting points.
Okay.
Could you repeat that for us, about so we can all make sure we got it?
The ionic compounds have higher boiling and melting points.
Yeah, do you want to go over all the notes for us and we'll check for understanding?
Yeah.
Or would you like to make another example to make sure you understand it?
Well, I think I've got it because we've got an ionic and a covalent. I think that takes out each point I had in my question. I've got the covalent, right? No, that's the ionic. And only one gets the electron. It's distinguished with a metal, and the boiling and melting points are high.
Yes.
Right. Now in the covalent, they share the same electron. They consist of two nonmetals, and the boiling and melting point is low. Got that right?
Yes.
I think I got it. This answers my question.